Welcome to Easy to See. In today's class, we will learn two forms of representing a logical function in digital electronics, which is sum of product. In short, we call that as SOP form, and the other form is product of sum. In short, that we call as POS form. And to learn about SOP and POS, we should have the concept of min terms and max terms, which we have already learned in our last class. First, we will learn SOP form and then POS form. So it's sum of product. So it's the logical sum of two or more logical product terms. Now we already know that logical sum means in digital electronics we understand OR operation, and by logical product we understand AND operation. So basically SOP or sum of product is an OR operation of two or more AND operation. Now this is an example where we can see y is a logical function which is represented by four min terms, and every min term has three logical variables a, b and c, and each variable is either in original form or in complemented form. So in this logical function we have four AND operation, or we can say four min terms, and between those four min terms we have three OR operations. Now this is another example where y is again a logical function which is represented by again four min terms, and every min term has three variables, but here the combinations are different. Now we will understand the canonical form of SOP. The canonical sum of product is the logical sum of all the min terms derived from the rows of a truth table, for which the value of the function is 1. So this is an example of canonical form where y is the logical function, and that logical function is represented by three min terms, and this is an unique combination of that logical function for which that function will have value 1. Here one interesting point about this canonical sum of product form is the logical function, if it has say n number of logical variables, then each min term will have all those n logical variables. Say in this example, as we can see, this function is formed by three logical variables. So here in all these three min terms, we can find all those three variables a, b and c. In the first format, we can see here that all the actual values of those variables, they are given either in the original form or in complemented form. And in the second format, what we can see, the number of that min term is given. We are already aware of this truth table having three variables and their corresponding min terms. So a bar, b bar and c bar, we already know that the equivalent min term is m suffix 0. So that min term is represented by m suffix 0 or m naught, and again the second min term is a bar, b, c. So from this truth table we can find that a bar bc is nothing but m3. So that min term is represented by its corresponding min term number, and the same logic is applicable for all other remaining min terms in that logical function. And this canonical form also can be given a compact form by listing only the decimal codes in correspondence with those min terms containing a function value of 1. That means that is another format by which we can represent that logical function, and again that will be an unique combination, and the function value will be again 1. But this time what we are doing, we are representing by this summation function, and at the bottom of that summation sign we are representing by small m. We know that small by small m we understand min term, and here within parenthesis or within first bracket we are just mentioning their decimal values. So m0, as we have seen, or a bar, b bar, c is the first min term, so we will represent its corresponding decimal value. So it's 0, 3, 6. So this is just a compact format, or it's another format to represent a canonical sum of product. Next we will learn product of sum. So it is the logical product of two or more logical sum terms. So again logical product, so logical product means AND operation in digital electronics, and logical sum means OR operation. So we can say this is basically an AND operation of two or more OR operations. This is an example where y is the logical function, and this has 4 max terms. Since this is product of sum, so this is represented by max terms, and we are already aware of the max terms. And in this example, what we can see is this logical function is represented by 3 logical variables a, b, and c, and each variable is either in original form or in complemented form. So in this example, what we can see is we have 1, 2, and 3 AND operations of 4 max terms, and in each max term we have logical OR operation. This is another example where again y is the logical function which has 4, or which is represented by 4 max terms, and each max term is represented by 3 logical variables a, b, c, and again here the combinations are different from the first example. Now again we will understand the canonical product of some form, which is the logical product of all the max terms derived from the rows of a truth table for which the value of the function is 0. Mind it, here it is represented by max terms, that's why the logical value of that logical function will be taken as 0. This is an example of canonical product of sum where y is the logical function. This is represented by 3 max terms. So here we have 2 AND operations of 3 max terms, and here also for each max term the concept is same, that if the function is represented by n number of variables, then in each max term we will have all those n number of variables. That means this time this logical function y is represented by 3 logical variables a, b, c, and that's what we can see in each max term. This is the truth table of 3 variables and their corresponding max terms that we are already aware, we have seen in our last class. And in the second format, here we have represented that same logical function by its corresponding max term number that we have in the first format. So here a plus b plus c is what? A plus b plus c. From this table we can see this is actually m suffix 0. So that's what it has been written. Then we have the AND operation, and then a, then b plus b bar plus c bar. So a plus b bar plus c bar is what? It is equivalent to m3. So that's what it has been written. And then again we have AND operation, and the same logic is applicable for the third max term also. And again, canonical POS form can be given a compact form by listing only the decimal codes in correspondence with the max terms containing a function value 0. So this time in the compact form, this is represented by pi instead of sigma that we have seen in canonical POS form. So pi, and then within bracket or within first bracket or parenthesis, just the corresponding decimal codes. So it was in the second format m0, m3, m6, so they are corresponding decimal values, that means 0, 3, 6. So today's class was about the basic idea of product of sum and sum of product and their canonical forms. In our next class we will learn that if any logical function is represented in non-canonical form, then how we can convert or transform that non-canonical form to its equivalent canonical form, and that we will learn with various examples. So stay tuned. Thank you.